Hello everyone, welcome to week 5 learning videos once again. This is learning objective 3, and in this learning objective we will see how we can develop an optimal risky portfolio and we can create an efficient front end for a group of stocks. So I will be dividing this learning objective into 3 separate videos, and in this video I will be showing you how we can calculate risk, returns and variance covariance matrix for a group of stocks. So I will be showing you it in Excel. This Excel file has already been uploaded in Blackboard, so you can get it. If you carefully look at this Excel file, we are given with a series of stocks. Those are BHP, Foster's Group, Fairfax, Harvey Norman, QB, and we also have WBC, Woolworths, and index, that is the all ordinaries accumulation index. That means it's an overall market index, and we are also given with a daily risk-free rate of return. So what we basically are given is we are given the daily closing price, and from this daily closing price we need to calculate daily returns. We are already aware how to calculate daily returns from our previous discussion. For example, if you look at BHP daily returns, how do we calculate it? For the daily return, the formula is today's price minus yesterday's price divided by yesterday's price. So that's the general formula we use to calculate daily returns. However, we have one additional factor here, that's dividend. So for example, for VHP in column B, we are given the closing price, and in column C, we are given the dividend. For example, you can see in 28 February 2005, a dividend was paid on the ex-dividend date. So to calculate daily returns after considering dividend, we have to add this dividend in the formula. So the formula now stands as it's today's price plus dividend minus yesterday's price divided by yesterday's price. So that's how we calculate daily return for BHP, and this is how we do the same for all other stocks as well. So after calculating daily returns, we need to calculate excess returns, and I think you also know that excess return is individual return from the stocks minus the risk-free rate. As I already have shown you that we have the risk-free rate at the extreme right column. So this D33, for example, here, that's the return from BHP, and then AG33, that's the return from the risk-free asset. So that's the excess return, and we calculate excess return for all other stocks in the same manner. Okay, so we have now the return and excess return for each of these stocks. So if we scroll down to the bottom now, we have some other numbers that we have calculated. First of all is the average daily return. So average daily return is simply the average of the returns that we have calculated for each of the stocks. So you can see that this is the average for the daily returns of VHP. This is the average of daily returns of Foster's Group. So that's simply the use of the average function. And then we calculate standard deviation. Standard deviation is also simply using the standard deviation function in Excel. We all know how do we use this standard deviation function to calculate standard deviation of daily returns. But the next issue is we need to calculate annual standard deviation. The reason is we want to convert this daily phenomena into an annual one for the ease of our calculation. So if we want to convert our daily return into annualized return, we will simply multiply the average daily return by the number of days in a year. In the same way, if we want to convert our daily variance into an annual variance, then we will multiply the daily variance by the number of days in a year. However, if we want to convert daily standard deviation, for example, this one to an annual standard deviation, we do not multiply the daily standard deviation simply by number of days in a year. We have to multiply it by a square root of the number of days in a year. The rationale behind this is, since the variance is the daily variance multiplied by the number of days, and standard deviation is the square root of variance, so annual standard deviation will be a square root of the number of days in a year. And the second point is the number of days in a year. In general, what we know is there are 365 days in a year. However, the stock market doesn't remain open all the 365 days in a year. So what we need to find out is how many days the stocks were traded in a year. So for simplicity, what we have taken is we have taken the average number of days in a year in our sample period. So if we look at the data series, we have the 5-year data, and we have taken the total number of days in a year. For example, if you take the total number of days here, you will see it is 1305. So we have this 1305 days, and since we have 5-year data, we divide it by 5 and we get the average number of days in a year, which is 260.8. So to convert our daily standard deviation to annualized standard deviation, daily standard deviation is multiplied by the square root of 260.8. Okay, so we got the annualized standard deviation. The next step is we need to calculate this variance covariance matrix. So as we know from our basic statistics course, is the covariance is the co-movement between two variables. So when we are calculating covariance between Foster's group and VHP, it actually shows the covariance or the co-movement between these two shears. Okay, and the correlation is simply a standardization of covariance. So where covariance shows you the co-movement between two stocks, this covariance is divided by the standard deviation of the two variables. So we get a correlation. It is basically a standardization, and it is expressed from -1 to +1. So to calculate covariance, what we do is we simply use the cover function. So you can see here the cover function, and cover function is the return from the individual stock that we have calculated and the return from the other stock between which we are looking after the covariance. For example, in this case, we are calculating the covariance between BHP and Foster's group. So this is this part is the return from BHP, and this part is the return from Foster's group. And we multiply it by 260.8 to get annualized covariance. Okay, so for each of these cell indicates the covariance or the co-movement between a pair of stocks. Now, if we calculate the covariance of the same stock, for example, you can see that covariance of BHP and BHP. So this part is the return of BHP, and this is also the return of BHP. So that's basically the variance, not the covariance, because that's the only stock. So diagonally, these are the variance, and the other cells represent the covariance between two stocks. That's why it's known as variance covariance matrix. Now, to calculate the correlation, like covariance, we use Correl function. So C-O-R-R-E-L, Correl. For example, in this case, it is the correlation between BHP and Foster's group. So once again, this part is the returns of BHP and this part is the return of Foster's group. So that shows the correlation between these two. As I come back to this variance covariance matrix again, you can see that I just have this variance covariance matrix for half of this total matrix, but I can populate the other half simply by putting the values in the top part. For example, in this cell, it is the covariance between BHP and Foster's group. Now, if I come here, this cell also represents the covariance between BHP and Foster's group. So it should be simply this value. Okay. So in this way, I can populate this half part and it will simply be look like the mirror image of the top part. That's why we do not absolutely need them at this stage. The next point we need to calculate is a beta, and we already know by this time that beta can be calculated either by running a regression where we regress excess return from individual stock on the excess return from the market, or we also can calculate the beta by using the slope function, where the excess return of individual stock and excess return of the market will be combined using the Excel function. Here I have calculated the beta using a different function, which is basically the cover, and this is the excess return from individual stock, and this is the excess return from market, divided by the variance of the excess return from market. So this is beta. Now either way you calculate using this cover function, using slope function, or running regression, you should get the same answer. However, you will see that sometimes there may be a very slight estimation error, so the results might slightly vary from approaches to approaches. However, either one is correct. So we calculated beta for each of these stocks, and then we calculate expected return. Now, you remember that we have calculated average daily return, so that's actually our historical return. However, we need to calculate expected return. And you also can remember that we previously calculated expected return using the CAPM model. We will be doing the same here. But to use CAPM model, you know that we need a risk-free rate of return, and we also need a market return. So for simplicity, at this stage, we will assume that we are given an expected market return of 9% and an expected risk-free rate of 5%. So to calculate the expected return, the formula or the CAPM model, you know, is the risk-free rate plus beta times the market return minus risk-free rate. So as I indicated, we have the risk-free rate that is 5%, and this is the beta that we have just calculated. Then return from the market, as we assumed, 9% minus the risk-free rate 5%, so that's a 4%. So that's the expected return of BHP, and we calculated the expected return for the other stocks as well. And finally, this is expected excess return. So in this case, we simply multiplied the beta with the excess return from the market. We didn't add the risk-free rate just to get the expected excess return. So now we have all the inputs to calculate an efficient frontier and to derive an optimal risky portfolio that I will be discussing in the next video. Thank you very much.